A-Level Pure 1 series. This is an exercise on the binomial expansion. There are two important results to remember. A plus b all to the power n is equal to n0 a to the n b to the naught plus n1 a to the n minus 1 b1 plus n2 a to the n minus 2 b2 and so on until plus nn a to the naught bn, where nr is equal to n factorial over r factorial times n minus r factorial. Now pause the video at this point and have a go at the 4 questions below. When you've finished, restart the video and I'll go through the answers. Okay, in question 1 part 1 we're asked to evaluate 6, 4. Now this means 6 factorial over 4 factorial times 6 minus 4 factorial. That is 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times, now 6 minus 4 is 2 factorial, so 2 times 1. Now the 4 times 3 times 2 times 1 cancels top and bottom, leaving 6 times 5, which is 30, over 2. So our answer is 15. In part 2, we're asked to find the value of 9, 7. This is equal to 9 factorial over 7 factorial times 9 minus 7 factorial. In other words, 9 factorial over 7 factorial times 2 factorial. 9 factorial can be written out as 9 times 8 down to 1, and 7 factorial can be written as 7 times 6 down to 1. 2 factorial is 2 times 1. Now the 7 times 6 times 5 down to 1 cancels top and bottom. So we're left with 9 times 8 over 2 times 1, which is 72 over 2 or 36. In part 3 we're asked to find the value of 11, 6. That is 11 factorial over 6 factorial times 11 minus 6, which is 5 factorial. So we have 11 times 10 times 9 times 8 down to 1 over 6 times 5 times 4 down to 1 times 5 times 4 down to 1. Now the 6 factorial can cancel top and bottom. So that leaves us with 11 times 10 times 9 times 8 times 7 over 5 times 4 times 3 times 2 times 1. Now, the 10 cancels with the 5 and the 2, the 9 cancels with the 3 to leave 3, and the 8 cancels with the 4 to leave 2. So we're left with 11 times 3 times 2 times 7, which is 462, and so our answer is 462. In question 2, we're asked to write the binomial expansion of various expressions. In part 1, we've got 1 plus x to the power 5. Well, the first thing to do is to write the powers of x and then add the Pascal row numbers. So the powers of x go 1, x, x squared, x cubed, x to the 4 and x to the 5. And the Pascal numbers go 1, 5, 10, 10, 5, 1. So our answer is 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the power 4 plus x to the power 5. In question part 2, we're asked to expand 1 minus 3x all cubed. Well, if we write the powers of minus 3x, we can then add the Pascal row numbers. So the powers are 1 plus minus 3x plus minus 3x all squared plus minus 3x all cubed. And the Pascal numbers are 1, 3, 3, 1. So if we expand that out and simplify, we get 1 minus 9x plus 27x squared minus 27x cubed. In part 3, we're asked to expand 2 plus x squared all to the power 4. Well, we can write in powers of 2 and x, and then add the Pascal row numbers. So we have 2 to the power 4 x squared to the power 0, which we don't need to write, 2 cubed x squared to the power 1, 2 squared x squared all squared, 2 times x squared cubed plus x squared to the power 4. And the Pascal numbers are 1, 4, 6, 4, 1. So if we expand and simplify, we have 16 plus 32x squared plus 24x to the 4 plus 8x to the 6 plus x to the 8. And in part 4, we're asked to expand 2x minus y all to the power 5. Well, if we expand it all in one go, the Pascal numbers will be 1, 5, 10, 10, 5, 1. So this will give us 1 times 2x to the 5 minus y to the 0, plus 5, 2x to the 4 minus y to the 1, plus 10, 2x cubed minus y squared, plus 10, 2x squared minus y cubed, plus 5, 2x to the 1 minus y to the 4, plus 1, 2x to the 0 minus y to the 5. And that simplifies down to 32x to the 5 minus 80x to the 4 y plus 80x cubed y squared minus 40x squared y cubed plus 10xy to the power 4 minus y to the 5. In question 3 part 1, we're asked to find the coefficient of x to the 6 in 1 plus x all to the power 9. Well, to solve this, in 1 plus x all to the power 9, we have the rth term, tr, is equal to n over r times 1 to the power n minus r times x to the power r. Now, if we want this to include x to the power 6, then the term is t6, which is 9/6 x to the power 6. So the coefficient is 9/6, which is equal to 9 factorial all over 6 factorial times 3 factorial. And if we write that out in full, we can cancel 6 factorial top and bottom. Now that leaves us 9 times 8 times 7 over 3 times 2 times 1, which is equal to 84. So the coefficient is 84. In question 2, we're asked to find the coefficient of x to the 8 in 2 minus x squared all to the power 9. Now we can see the term including x to the power 8 in 2 minus x squared all to the power 9 is 9, 4, 2 to the 5 minus x squared all to the power 4. Now the reason is that minus x squared to the power 4 will make x to the power 8. So the coefficient is 9, 4, 2 to the 5, which is 9 factorial over 4 factorial times 5 factorial times 32. Now if we write it out in full, we can cancel 5 factorial top and bottom. And that leaves us 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1 times 32. And we can cancel the 8 and the 4 to leave 2, and we can cancel the 6 with the 3 times 2. So that leaves us with 9 times 2 times 7 times 32, which is equal to 4032, and so the coefficient is 4032. Now in part 3, we want to find the coefficient of x to the power 6 in the expansion of x squared plus 2 over x all to the power 6. So we need to find which term in the expansion includes x to the power 6. Well, let's assume that it's term r, where tr is equal to 6r x squared to the power 6 minus r times 2 over x to the power r. Now let's just consider the parts of the expression that include the letter x. Now that's x squared to the power 6 minus r times 1 over x to the power r, and that has to equal x to the power 6. So simplifying, we have x to the power 12 minus 2r times x to the minus r is equal to x to the power 6, or x to the 12 minus 3r is equal to x to the 6. So equating the coefficients, we have 12 minus 3r is equal to 6, or 12 minus 6 equals 3r, which tells us 3r is equal to 6, which means r equals 2. So the term is 6(2) times x squared to the power 6 minus 2 times 2 over x to the power 2, which is 6 factorial over 2 factorial times 4 factorial times x to the power 8 times 4 over x squared. Now, if we write that out in full, we can see that we can cancel 4 times 3 times 2, top and bottom. And that leaves us with 6 times 5 times x to the power 8 times 4 all over 2x squared, which simplifies to 60x to the power 6. So the coefficient is 60. In 3 part 4, we're asked to find the constant term in 2x plus 3 over x cubed all to the power 12. Now to solve this, we need to find which term in 2x plus 3 over x cubed all to the power 12 includes x to the power 0. So let's assume it's term r, which is 12r times 2x to the power 12 minus r times 3 over x cubed all to the power r. And if we just consider the parts of that expression that includes the letter x, we've got x to the 12 minus r times 1 over x cubed to the power r is equal to x to the power 0. We can simplify that a bit. We've got x to the 12 minus r times x to the minus 3 to the power r is equal to x to the power 0, which means 12 minus r minus 3r is equal to 0, or 12 equals 4r, which means r is equal to 3. That means the term is 12(3) times 2x to the power 12 minus 3 times 3 over x cubed to the power 3, which is 12 factorial over 3 factorial times 9 factorial times 2 to the 9 x to the 9 times 3 cubed over x to the 9. That gives us 12 times 11 times 10 times 9 factorial over 3 times 2 times 1 times 9 factorial times 2 to the 9 times x to the 9 times 3 cubed over x to the 9. Now we can cancel the 9 factorial top and bottom. So that leaves us with 220 times 512 times 27, and the x's cancel, which gives us an answer of 3,041,280. So the constant term is 3,041,280. Now we're asked in question 4, using the fact that 0.97 can be written as 1 minus 0.03, calculate 0.97 all to the power 4. Well, 0.97 all to the power 4 is 1 minus 0.03 to the power 4, which can be written as 1 plus minus 0.03 all to the power 4. So if we use the binomial expansion, the terms are 1 minus 0.03 to the power 1, minus 0.03 to the power 2, minus 0.03 to the power 3, and minus 0.03 to the power 4. And the Pascal numbers are 1, 4, 6, 4, 1. So this simplifies to 1 minus 0.12 plus 0.0054 minus 0.000108 plus 0.00000081, which is equal to 1.00540081 minus 0.120108, which equals 0.88529281, and that's our answer, 0.88529281.